We now introduce bivariate normal distribution. So this is the most important joint distribution function. And say suppose x is a random variable which is normally distributed. The mean is mu of x and variance is sigma x square. That is, expectation of x is mu of x and the variance of x is the square term here. And y is also normally distributed with mean mu of y and variance sigma square y. But both x and y have non-zero correlation. So x and y are not independent. So you have a non-zero correlation. Remember, correlation is nothing but covariance of x comma y divided by square root of variance of x times square root of variance of y. So this long expression is the joint density function when x and y have non-zero correlation. So 1 by 2 pi sigma x sigma y, 1 divided by square root of 1 minus rho square, and then you have exponential minus 1 by 2 1 minus rho square, you have x minus mu x by sigma x square. Similarly for y minus mu y over sigma y square, and then you have minus 2 rho times x minus mu x times y minus mu y divided by sigma x sigma y. Now we want to find the conditional density of x given y. So you're given this function and you want to find this. That is, you want to condition random variable x on random variable y. So you use the formula, and then after some calculations you will get a normal distribution which has the mean. So x conditioned on y is again a normal distribution. So the mean of that distribution is mu x plus rho times sigma x by sigma y times y minus mu y, and the variance of this conditional distribution is sigma x square times 1 minus rho square. So notice that if x and y are independent, then rho would be 0, and in that case the normal distribution would just be, so if you put rho 0, will be mu x times sigma x square. That is the same here, same as here, if rho is 0. Since rho is not 0, this is what the conditional distribution of x and y will look like. So x conditioned on y, and this is their joint distribution. Now obviously you could just reverse mu x and mu y and you could find the conditional distribution of y given x. So this will again be normally distributed. So instead of mu x you have mu y plus rho times, instead of sigma x you have sigma y, then you have x minus mu x, and the variance would be, so that is it.